all once again to this webinar series, which we are organizing as a part of the Azadi Ka Mahotsav, under which we are organizing 75 seminars. We have completed almost 54. And this is to celebrate and commemorate 75 years of independence, which is a reflection of the hard work, innovation, inspiration, good governance towards global peace and development. See, whenever I come for introducing, I always look up for more and more things which this Azadi Ka Amrit Mahotsav is incorporating, what it actually means. So all the hard work, all the good governance, all the activities which we have been doing towards achieving this 75 years of our independence, that is what is reflected in Azadi Ka Amrit Mahotsav. That is why we are celebrating. So we have a target of about organizing 75 seminars, and I told you we organized more than 50. And in this, we are trying to invite speakers. We have varied knowledge in different sectors, whether it is RE sector, or it is sustainable environment, or it is waste management. Now, one of the most important area is solar energy. The other day, I had gone for a conference where Minister had highlighted that with solar energy, wind energy and hydro energy, which we will surely fulfill our target or our mission of the gigawatts which we have set up. So solar energy has become very important, and this is one which we are promoting hard on. This is something which is taken on very well. Now, solar energy, when you talk of the sun's energy, we know we can harness this energy, either it is through the electricity route, that is the PV route, or we can do it by concentrating the solar energy and using the heat for directly, or we can use it for electricity power generation. This can be a source or an industrial application for our industrial applications, institutional applications. And this is what our learned speaker, Dr. Pankaj Kumar, is going to share with us through his talk. I feel his illuminating talk, and I welcome him and thank him for accepting our invitation to be a part of our webinar series. Welcome, Dr. Pankaj Kumar. And I request Mr. PV Singh to kindly introduce him and tell us more about him before we listen to him. Over to you, Mr. PV Singh. Thank you very much, and welcome all once again. Thank you.
Thank you, ma'am. Thank you, sir. Thank you very much for welcoming the speaker. Good morning, everyone. I'll welcome to all of you in the 54th series of webinar. Skill Council for Green Jobs, SCGJ, is organizing a series of webinars to celebrate Azadi Ka Amrit Mahotsav as a part of India's celebration of 75 years of Independence Day. In this series, SCGJ is inviting eminent and learned speakers in different sectors on sustainable development, renewable energy, and waste management, so as to deepen the understanding of recent development in these sectors. The first in the series was launched on 24th September 2021. Today we have very experienced, learned, distinguished speaker who will be sharing his expertise and experience on use of concentrating solar thermal technology for industrial and institutional sectors in India. Dr. Pankaj Kumar is the national technical expert working in UNIDO regional office, India. Dr. Pankaj Kumar did PhD in energy, MTech in energy management, MBA HR, MSc Physics, and postgraduate diploma in integrated rural energy technology. Dr. Pankaj Kumar is an energy professional with experience in solar energy efficiency and climate change mitigation of GEF4 and GEF4 funded projects. He has been extensive working on development and diffusion of cleaner and renewable energy resources based on technological solutions in India. For close to, he has a more than 18 years experience with bilateral GIZ and multilateral UNDP and UNIDO agencies. His experience includes project management monitoring of JF funded UNDP, UNIDO projects jointly with Indian Ministry under the GAF focal point of MOEF and climate change. He has received several prestigious awards, including ICNEER Award for Sustainable Work and Contribution of the Solar Energy. Thank you, Dr. Pankaj. Now over to you, Dr.
Thank you, sir.
Pankaj.
Thank you for introductions, and thank you for inviting me for an as speaker, guest speakers, to speak about using the concentrating solar thermal technology, because this is a very important for the Indian industrial prospects. And this is the right times to use, because as you know, in concern to the efficiencies with the respect to the solar is a very important. So awareness and the policy both are very important. So I'm just trying to cover all the points for the concentrating solar thermal technology, which is very useful for the industries, institution, even in the religious sectors. So I'm just trying to share my slide also. Can you just give me some permissions to start the sharing?
Sir, I already gave you the permission.
Is it visible now?
Yes, yes, it is visible.
Yes, sir.
So good morning to all of you, and I'm very thankful to the SCGJ to invite for as speakers to say something about the use of concentrating solar thermal technology. And my purpose for the deliver lectures with respect to the industrial prospects, because as you know, UNIDO is a very specific to looking for the industrial prospect under the SDG 9. So I'm just trying to cover the SDG 9's prospects. But as you know, the CST is applicable for the institutions as well as the religious sector. So I'm just sharing some case study which the eminent which install the systems, and still the systems are functioning well. So UNIDO is the specialized agency for the United Nations with the unique mandate to promote and accelerate sustainable industrial and economic development under the for the SDG for the SDG 9. Industries, innovation, and infrastructure is the very specific for the UNIDO point of view, and we are working on the SDG 9 for the projects like promoting business model for increasing penetrations and scaling of solar energy with under the JEF funded project with Ministry of MSME. So before going to start, because as you know, this is the industrial prospect, so we need to understand the global energy prospects, because most of the industries they are using some conventional fuel, and they depends on the conventional fuels, because and right now today the scenario is not for the reducing the conventional fuel, but important thing is the greenhouse gas emissions, and that is the way the worldwide which they are trying to discuss on how to reduce the dependency of fossil fuels, reduce the greenhouse gas emissions. So in that way, I'm just sharing some figure, and you can try to understand. As you know, the final energy consumptions in 2013 was almost 9,300 or 9,500 metric ton of oil, like that, and against the 13,500 metric ton of oil produced. And the data increase that world depends on, you can try to see the three major prospects for the natural gas, coal, and oil. If we can think about how we can try to reduce the dependency. I'm not looking for the 100% reduce the dependency of the fuels, but at least for the during the 6 sunny hours, or maybe the 6 to 7 hours, we have an options to reduce the energy. And worldwide, the technology which they are using, and they are very easy to integrate with the industries which they use in the thermal process. And you can try to see in the 80% of the total global energy, like natural gases 21%, coal 28%, and all 31%. It means 80% energy requirement is made by all the three fuels. So we need to think about how we can reduce the thing. Even in the Asia prospects, Africa, Middle East, OECD, and others, you can try to see the energy consumption. Even we are talking for the Asia point of view, 33% energy, which they are which they are using through the natural gases, coal, and oil, even in other fuels. And what is the factors? Because if we are using the conventional fuel, like an example of coal or maybe the some diesels, every fuels which they are producing they affect on the environment, because the important thing is the CO2 abatement is a very major prospects in concern to the country wise, and we need to look for how to reduce the things. And if the industries which they are using the coal, because as you know right now, this is the limitations of all the fuels, and there is options to look for the some alternative fuels, maybe the waste heat recovery, or maybe the some solar point. So rightly, I'm just saying, because as you know, if we talk for the solar, there is a two concepts which we understand: the electricity as well as the heating, and which they are coming through the solar photovoltaic and even in the thermal process. And if we are talking for the thermal process, industries are the major concerns, which they use process heating, cooling, and some other applications, because the major concern is the wastewater treatment also. So I'm just trying to cover in the factors of thermal heat. So I will share all the information which is concerned to the heating in the industries using for the different applications, because the electricity which they use, like an example of solar photovoltaic, which they use for the electricity. But thing is there, if you're trying to compare in concern to the industries, not for the residential point of view, compared to the industries for the thermal efficiencies, of course, the thermal is a major hold for the efficiencies for the industrial point of view. Of course, the India is a leading in very close to some others. I will share you some data in the worldwide, but that is the way, that is the right times, because as you know, the most of the industries which they understand and they adopt the technology, either there is options to use in somewhere like ground waste or ground installation and rooftop, even in the corrugated roof, because the project developer, they have no options to install in somewhere in rooftop also. So that is the way which we are very easy to install in somewhere, and they can use for the thermal process. My concern is, if we are looking for the thermal point, what is that is a very important. If we are talking for the thermal applications in India, I'm talking for the Indian point of view, what is the exact potential of CST? CST means concentrating solar thermal technology, which they use for the industries for the process heating, like in steam generations or the pressurized hot water. Because as you know, if you are talking for the solar thermal, there is a two technology like solar water heating systems and CST, concentrating solar thermal technology. Solar water technology, which they already matured, and they can use either for the industries for the low temperatures, which the temperature required 40 to 50 degrees, even in the residential sectors for the bathing purpose or some other applications, which they use solar water for the different way. But if we are talking for the CST, industry is a major chunk like that. So we need to look for the how we can try to aware to the industries, so that the industry will come forward and adopt the technology for the thermal process, because every industries they have in a boiler. So we need to think about how they try to reduce the boiler load using the conventional fuels. So that is my first concern. What is the potential of CST? Is it possible to accelerate the growth of CST or not like that? So I'm just trying to cover all the points. This report is already developed by the UNIDO, and it's available in the FIC ISID sites. So it's very easy to understand for the how much energy which they use, and what is the total industries which they are trying to assist during the find out the potential of CST. Second point is the thermal point of view, because solar thermal technology is useful for the thermal process, but the important thing is the efficiencies, because if we compare to the electricity and thermal, we need to think about which one is better for the efficiencies point of view. And if we look for the ground, even in the we can say not even in the laboratories, thermal laboratory in terms of efficiency, if we look for the end users which they use the technology, and what is the exact efficiency which they are trying to cater all the things using for the thermal process. Second point is, it is applicable during non-sunny hours. What is the exact things? Either, because if we are talking for the PV, there is options to look for the battery storage, but in thermal, this is the possibility to look for the storage facility or not. So we will try to cover the storage facilities also. How the technology will integrate with the existing boiler. are the suppliers are understand the thermodynamics engineering or not, because this is the very important, and UNIDO is very specific for the thermodynamics, because as you know, the process engineering with respect to the integration is a very, very important. Whatever the energy demand by the industries, we need to fulfill by the solar thermal. So that understanding the thermodynamics or maybe the process engineering is very, very important, because as you know, ultimately we need to look for the functioning of the system for the maybe the maximum 20 years. So we need to look for the process engineering even in the designing point of view. GHG emission reductions. What is the exact things, how we can try to monitoring all the point for reducing the CO2 abatement. So there is a possibility to look for the reducing for the GHG emissions. What is the impact like that? Because the industries, even in the international market, they are thinking about, they are using some alternative fuel, which they are trying to reduce the energy or not. So in the international market, they are very specific for you, specific in for the trading like that. Either they are using the solar or maybe the waste heat recovery, so that they can understand to reduce the conventional fuel in the industries. Is it applicable for the carbon credit? Because we are talking for the carbon credit, because the carbon credit is, what is a carbon credit? Because it's ultimately linked up with the greenhouse gas emissions, either using for the solar photovoltaic, either using for the solar thermal, or maybe the energy efficiencies technology like that. So all the things which is link up with the greenhouse gas emissions or reduce the CO2 abatements. So I'm just trying to cover the solar process heating, because as you know, we understand the electricity point of view. Even in the we cover the 4 vertical component: industries, transport, and residential, and others we will try to cover all the industries. You can try to see 26% which they use electricity, and 74% is a very, very major point we need to think about. 74% which they use for the heating applications. So if they are using the heating application, you can try to see the coal, natural gas, oil, and some other fuel, which they totally depends on the conventional fuel for using the thermal process. So we need to think about how we can try to integrate and how we can try to give proper solutions which they use concentrating solar thermal technology. And if you are looking for the 74% of the energy, which is very important to categorize in the 3-way, because as you know, in the industries, there is a 3-way for the low temperatures, low medium temperatures, or maybe the high temperatures. If we are talking for the high temperatures, they are talking for the power generations, like we call as a CSP, concentrating solar power. If we are looking for the low medium temperatures, the CST is applicable. CST is the technology which we are very easy to achieve temperature 200 to 250 degree temperatures, because as you know, for the process heating in the industries, they are not asking for the temperature more than 200 degree centigrade. So the CST is comfortable to integrate with the boiler like that. 30% of the energy, low temperatures like that. If you are talking about the low temperature, maybe there's some cleaning of the utensils, or maybe there's some other application. It is applicable using either through the solar water heating systems, which we call as a flat plate collectors as in a technology point of view, or maybe the evacuated tube based on solar water heating systems. So I'm just trying to cover in the 74% of the energy for the low medium temperature. You can try to see for the industries like chemical, food, machinery, mining, textile, wood, which they are using the applications like boiling, drying applications, cleaning and drying, even in some electrolyting refinings, washings, and steaming, picking, even in a medical point of view, because they are looking for the sterilizations also, because they need pressurized hot water more than 90 degree temperature. So the technology is applicable, which they use in the hospitality sectors also, hospital sectors. If you are talking for the medium temperature, 150 to 400 degree temperatures, you can try to see about the evaporations of the waters, which they can use for the wastewater treatment in the industries. And this is the major important point for the industries, how they can adopt that technology basically for the treatment of wastewaters. I'm just avoiding the high temperature, because if you are talking for the high temperature, the technology which is available for the concentrating solar power, which they generate a steam using through the turbine to produce the electricity. So I'm just sharing some snapshot of the solar thermal technology in the worldwide. They in 2015, 622 million square meter collector area, which they install. And if we are talking for the power in terms of power, you can easily convert from the collector area to the power generations like that. And as we concerned in 2015, 435 gigawatt, you try to see for the using the solar thermals, China is a 71%. But right now, this is the figure on 2015. But after the 5 years, the India is going ahead like that. They are adopting the technology, especially for the wastewater, desalinations, and others. So I'm just trying to see the figure, sharing the figure in 2015, India is 1.3, but drastically increased like that. So if we are talking for the CST, the two countries are leading for the China and India, but rest of the things which they are using for the low medium temperatures using through the solar thermal. So for the India point of view, for the installations, if you are talking for the CST, if you are talking for the solar water heating systems, for the solar water heating systems, already achieved more than 15 million square meter collector area till date like that. And if you are talking for the concentrating solar thermal technology, this is a very important. It's a very, very important because we need to look how we can generate the awareness to the industries so that the technology will adopt. Solar water already proven like that. The CSTs are still looking for the industry's point of view. They can try to update reducing the coal because, as you know, the cost of the coal and ability of the coal is very, very important. Now the CST is still 75,000 square meter collector area, which they install in India like that. The figure is, I'm just sharing in the 2017. And you can try to see for the roadmap, which we developed under the UNIDO. Because as you know, the assessment identify the potential for the CST is very important. We understand the solar water either will cover to the residential, industries, religious institutions. But industry's point of view, we assess 25 industries, and when we assess 25 industries for the various applications, because the type of industries, the applications are different. If we are talking for the textile, they are using the different application. If you are talking for the dairy, their application is different. So every industry, they are talking for the heating applications. Of course, the application is different, but our ultimate goal is how we can try to achieve the temperature. If we are talking for the applications like cleaning, drying, even evaporations, distillation, pasteurizations, even in the cooking also, because most of the industries, institutions, religious, they are installed mega scale for the cooking applications. So we need to think about how they can try to make to use as an applications for the cooking application. And most of the institutions for the hostels, they install the system using for the cooking applications. If we are talking for the process heating, if process heating, the application is different like that. If we call as an preheating boiler feed water, maybe the cooling, maybe the evaporations. If we are talking for the process heating, all the industries are covered under the process heating. So we need to think about as in one single goals for the process heating applications, and they are very easy to achieve the temperature. Either we are talking for the pharmaceuticals, we are talking for the chemicals, because the major industries they are using, and they are the challenge is how they are trying to reduce the thermal load. Because as we visited the few places in some clusters under the MSME, we analyze the sectors are facing lots of difficulty ability of the conventional fuel, especially for the coal. So we are trying to pitching the technology. They can try to adopt the technology using for the some certain applications like that. So the pharmaceuticals, even the rice mills also, even the tea processings, if you are talking for the chemical industries, if you are talking for the textile, because Ministry of MSME, they identified the 5 clusters under the UNIDO, and they are trying to thinking about how the CST technology, which they install in 5 sectors, so that they can accelerate the growth like that. So that is the way the UNIDO is come forward to support to the some industries. And here I am trying to promote the technology, adopting the technology for the industrial point of view. Now we'll come to the potential point of view. As we understand for the market potential or the technical potentials, if you are talking for the technical potential for the CST, that is the target is near about 13 or 13.3 gigawatt thermal like that. If you are talking for the market potential, because the factor which is come from the present energy as well as in the market potential, you can try to see the total energy load for the 1000 terawatt in 2013-14, where we can target as an find out the some constant, maybe they including the space also, maybe they including for the some other factors. So because the other factors which we call as in a DNI, like the radiation is very important, because India is a topological country, and radiations which they identified and selection of technology is better. So most of the factor which we included and find out the things, the total CST potential in India is right now 6.45 gigawatt, especially for the CST, not for the other solar thermal. I'm talking for the concentrating solar thermal technology, especially for the industries. So you can try to see the 6.45 gigawatt thermal, which they are very easy. They have a target. So we need to think about, we need to find out the awareness point of view, we need to find out the technical point of view, we need to find out the demonstration and scale up, even in the financial model. Because as you know, in the 75,000 square meter is very close to 50 or 55 megawatt. We need to think about how the government, how the UN agencies or the other agencies will accelerate the growth, because the industries are looking some way forward to solutions in terms of what are the energy demand and what we can try to supply like that. So in between the demand and supply, we need to think about to give it to the proper solutions to the industries. So in that way of replication, the probability of replication is going very high like that. So this document is available in our FIC ISID site. If somebody will asking, you can try to send it to the mail, or maybe share with the asking for the mail regarding the documents. We'll share the link and you can find it and you can read also. So I'm sharing some case studies for the solar or thermal, which they install under the UNIDO point of view. As we understand, solar air heating for the drying for finalized leather in Kanpur. Kanpur, they are using for the solar watering system, because they don't require the much more temperature, more than 50-60 degree temperatures. They already installed under the UNIDO project and using for the leather industries. If you are talking for the some industries, because both the technologies are different, evacuated tube collectors and flat plate collectors, the temperature requirement is 60 to 70 degrees, because in the leather industries, the application is different in different way. If we are talking for the wastewater, even in the treatment of the water, we need to think about the highly efficient CST technology. Now come to the dairy sectors, because under the UNIDO project, which we install a system in Amul Dairy in 96 parabolic trough with the collector of 600 square meter collector area. And you can try to see they are looking for the steams for the different applications. If we are talking for the pasteurization, if we are talking for the CIP, and they are using very comfortable like that. Even in the mother dairy, which they install systems for the pasteurization and other applications. And both the sectors, you can try to see the technologies are different. So I'm coming to the next slide, or maybe the later. I will give it to the information of what is the exact technology, how the types of technology based on the requirement is very important. The selection of technology is the factor of efficiencies, is factor of the temperature requirement, is factor of the DNA ability, because India, if southern regions, in the eastern region, western region, and even in northern region, the radiations levels are different. So we need to think about the selection of technology. It's directly linked up with the cost economics. So if we are talking for the some textile units like silk reeling unit, which they install in compound parabolic collectors, and the systems are functioning well, they are using for the pressurized hot water in different applications, because they are using the wood, and now they reduce the wood and using the solar, because their requirement is 8 to 9 hours, and the systems are functioning well in somewhere in the Dehradun. Next, I'm sharing the pharmaceutical industries, the system which they installed in last year in 21, and the systems are functioning well. The important thing is they are trying to reduce more than 150 liters of diesels. And that is the way the payback will drastically come down in 3 years, because earlier the expectation is the payback is 4.5, but the cost is going high in the diesel, in concern of diesel. The payback will drastically reduce like that. And the second advantage of this technology in the natural capsules limited, they cover the system installed in rooftop, and as during the summers, the cooling which they are using, the cooling, the electricity load is going very high. So they are trying to cover using the CST, and they reduce the electricity load at around 10 to 15%. So this is the second advantage using in the pharmaceutical sectors. Benefit, of course, the reductions of energy use and cost is very important. Risk reduction in fuel storage and use, GHG emissions, Advantage of technology: decarbonization of heating energy, thermal energy storage, low operation, and is negligible maintenance like that. Cleaning of collectors are important like that. So we need to think about how we can try to periodically clean the collectors so that we can think about to capture more heat. And because the dust is a major issue, so we need to think about how we can try to maintain the systems very easily like that. Now, come to the solar radiations point of view, because the technology is directly dependent on the radiations. If the radiations are low, we need to think about the selection of technology. If we think about the India, the radiation which is available in 3.5 to 4.5 or very close to 5 kilowatt hour per meter square per day, and the technology is very easily working in the way of where the radiation is very good like that. And but as concerned to the northern eastern regions, the DNA is the major important factors. So we need to think about which technology is better for the selection of technology. And this is the challenge of our projects, how we can try to pitch the technology using the northern eastern area. Because as right now in CST technology, there is a challenge. The industries is very keen to adopt the technology, but the important thing is the payback period, because the radiation and energy generations with respect to the technologies are very, very important. So we need to think about the thermodynamics, energy and process engineering. And we are working very closely with the tea industries also, and we need to think about how we can try to adopt, install the systems in very soon like that. Even in the, if we are talking for the Gujarat area or southern regions, the radiations are very good, and industries are right now, they aware, they understand the technology point of view, and they are looking for the on baby, and they can very easily maintain by the boiler operators and some other trained peoples like that. So if we are talking for the, if we are sharing some example for the wastewater, and even in the southern regions, they are using for the wastewater treatment in the leather industry. So I'm coming after that. So I will share you some information which they are currently install the system, but we don't have any exact information with respect to the performance data. So I will share you some concept dynamics so that you can understand which the technology is using for the wastewater treatments. That the technology is working. I just share how the technology is working. That this is not a rocket science like that. The technology is working as a magnifying glass. They concentrate on one particular point. So if we concentrate on one particular point, which they generate heat like that, either the paper will burn like that, or maybe capture more heat. So this way we need to think about how the CST concentrate. CST means concentrate solar thermal technology, and that is the way the magnifying glass is one of the best example, so that you can understand what is the principle, what is the working principle of CST. Second point is the tracking mechanism, because earlier we don't have any tracking mechanisms. So we need to think about how we can to provide all the information with respect to the tracking mechanisms, so that we can capture more it. Earlier we are using the single axis technology is to waste like that. So the capture in seasonal variations with respect to the dual axis are very important. So now the dual axis technology is available, and they are trying to install the systems in somewhere in most of the industries. This is the principle like that. So if we are saying the red block, you can try to see the concentrate on one particular point, and they are generate heat or in terms of steams. So it's a small boiler which they are concentrate on one particular point through the reflectors, and they are generate steams, maybe the temperatures up to the 180 or 200 degree temperatures based on the ability of technology. And this is the tracking mechanisms. So they can capture more heat during the sun tracking or sun tracking. So that the important thing is that whenever the heat capture more heat, when we capture more heat, and it is directly linked up with the cost economics. Whatever the energy demand and what is the capture through the CST is directly linked up with the reducing of the fuel which they are using for the steam generations, or maybe through the coal or diesel and some other fuels like that. So now I come to the types of technology. You can try to see we have 6 technology available worldwide. And we are talking for the characteristics of the technology, and all the technology, the characteristics are different because the optical efficiencies are different for the different technology. If we are talking for the parabolic trough, it's available, but parabolic trough is also useful for the power generations. But right now, if you are talking for the heating, for the process heatings, we need to think about how the energy demand and is it applicable for the some other technology with respect to the cost economics. So the assessment is very important, and selections of the technology is very important. Schaeffler dishes is also important. So third is the linear Fresnel reflectors, Fresnel reflectors, paraboloid dishes, compound parabolic collectors. So we need to think about which technology and which technology is useful for the applications point of view. So this is the type of technology. We have the size of the parabolic trough, which is available from 2 square meter up to the 30 square meters for the parabolic trough collectors. And this is the fact of temperature range, which if we are using the non-evacuated heat receivers or the evacuated heat receivers. So we need to think about how much temperatures we need to get like that using the parabolic troughs. Weight is per square meter is different, so you can try to see. And suitability, it's a single axis technology to capture more heat for the process heating and as well as the compound parabolic collectors. Now come to the Schaeffler dishes. Schaeffler is, of course, the Schaeffler is a scientist, is the German scientist, which they invent the technology. If we are talking for the shape, like parabolic trough, the shape is like an elliptical dishes. We call as an elliptical dishes. Elliptical dishes, which they are using for the cooking application. Mostly they are using for the cooking applications. But right now there is some successful case study using the Schaeffler in the Brahmakumari ashram for the power generations. So the power in the Brahmakumari ashram is one of the place which they use the same technology for the cooking application as well as the power generation, and they generate more than 1 megawatt using the Schaeffler dishes. So this is the right place. I think somebody will maybe try to visit and see the performance and all the things. The technology is still working, and if we are talking for the cooking applications, the technology which they installed in 1992 and still the systems are functioning due to they can take care of on baby. So the maintenance point of view is very, very important. There is no need to look for the higher investment cost of operation and maintenance. But if the people will understand how we can try to clean, how the people will train to operate the systems are very important. So this is the Schaeffler type of technology. The Schaeffler which they started is the size of the Schaefflers which are available 6 square meter up to the 60 square meter. In Brahmakumari ashrams, they install a system in 7 square meter and for the cooking application, and they already installed for them 60 square meter for the power generations. This is the fixed receiver, single axis, and if you are talking for the fixed receiver elliptical, this is for the dual axis tracking. You can try to see the temperature variations. Of course, the temperatures are important for the various factors. So I'm just come to the slides to share what is the exact factors which we need to think about to get more temperatures. This is a linear Fresnel reflectors. Of course, this technology is especially using in the southern regions for the desalinations applications. Of course, in the one of the manufacturer, where they install systems for the desalinations process. And this is the fact sheets for the linear Fresnel. Of course, in the worldwide, this technology is using for the dairy sectors also, even in the power generations also. Arun dish, which the size of the dish which they available in 30 to 160 square meter, using in the industries, like an example of NTPC, Netra, which they install a system using for the cooling applications. Even in the, if we call as an Akshardham, which they use in a system for the cooking applications as even Arun dishes which they install in the dairy sectors for the pasteurization. So the technology which they install in various applications in different regions. Paraboloid dishes, the system installed in the dairy sectors, the system installed in pharmaceuticals. The important thing is the tracking mechanisms, and you can try to see the beauty of the technology because the paraboloid dishes which are available in different because the manufacturers are develops different type of paraboloid dishes, and still the systems are functioning well. And I already shared the one case study for the paraboloid dishes which they install in natural capsules. Cylinder is a very small size of its collector area, is a 4 square meter. The total area which they install in natural capsules limited is 286 square meter, and still the systems are functioning well due to the easy to operate and maintenance by the supplier as well as the end users. The system installed in pharmaceuticals also, even in the dairy sectors. So and this is a very highly efficient technology which we capture more heat in compared to the other. For the Arun dishes, if we are talking for the 100 square meter or 169 square meter, of course, the load is very, very important. If the system installed either on the rooftop or maybe the ground is very important. If somewhere in the space is major constraint like that, like example in the Arun dishes, in one of the example in ITC Moria and Delhi, they don't have any space. So what is the beauty? They are trying to distribute the load, because in the footprint area which they cover 3 square meter collector area, but the ditches is 100 square meter collector area, and they install systems for the dairy applications in ITC Moria. Now come to the last, even the compound parabolic concentrator. Earlier, the CPC is not proven like that, because the important thing is the concentrations ratio, because the tube which they use for the solar water heating systems, but the important thing is the compound parabolic, even the reflectors are very important during the diffuse and DNI radiations. So that is the way, the beauty of the technology which they use, very easy to for the cooling applications, because earlier the CPC is not matured and they install a parabolic trough collectors for the cooling applications. But in terms of payback period, in terms of cost investment, even in the DNI regions is very, very high. So right now the technologies are matured, and CPC is one of the best technology using for the cooling applications, because in the industries they are thinking about the cooling point of view. And right now, earlier they are using for the pressurized hot water, but for the especially for the cooling, they install more than 26,000 square meter collector area. An example is Swiss Embassy, which they use for the cooling applications. Second example in the Gandhinagar, which they use the systems for the cooling applications. And before that, I just share the parabolic trough collectors, because the technologies are same, but you can try to see the two regions like Rajasthan and even in the Andhra Pradesh, which they use in the same way for the cooling applications, but the size of the systems are different due to the radiations. In the NPTIL, for the in the Rajasthan as in a power atomic centers, like they're using 650 square meter, but in Honeywell they are using the 800 square meter due to the radiations difference and the cost investment like that. I just shared compound parabolic collectors already matured like that, but right now the technology is come and they are given more efficient in terms of heat generations. If we are talking for the cross compound parabolic collectors, right now the technologies are very, very highly efficient. The cost is low in compared to the other technology, and they use in various applications, because the industry they are looking for the more heat generations. If we are providing more than 90-degree temperature, they are very happy like that. And the systems which they install in UAE for the desalination purpose, and right now in India, the technologies are drastically, the growth of the technologies for the installations point of view is increasing very fast. Like example of wastewater treatment, they are generating 1.5 ton per hour steams using the CPC technology. If we are talking for the CPC, they will not generate the steams. But if we are talking for the cross compound parabolic collector, they generate steams. And this beauty of this technology is already US patented technology, and they install systems in under the UNIDO project in Ranipet for the wastewater treatment, and they generate 1.5 ton. And I just understand this is the one of the biggest project for the wastewater treatment in Ranipet for very close to 1700 square meters area. And that is the way which we under the industries understand the selection of technology and the cost economics. So now come to the factors, because all the factors are linked up with the thermal efficiencies. And if you are talking for the efficiency point of view, latitude means places like that. If you are talking for the northern eastern, the latitude is different. If you are talking for the Leh Ladakh, the latitude is different. So the ability to identify the place is very important to find out the some technology. DNI is very important, direct normal irradiations. Of course, some of the places which we need to capture the diffuse radiations also. Ambient temperature, wind velocity, and temperatures like that. Now they come to the point of industries, because industry will not allow to touch the existing systems, because there is some procedures and protocol. But solar is one of the way which they are very easy to integrate with the existing systems through the boilers, and the systems are functioning well because they have a condensate heat using through the CST. Whatever the energy which they recover through the condensate, they can directly integrate with the solar instead of feed water tanks. So in that way, they capture more heat and they provide more heat in the process of thermal process before going to the boilers like that. So this is the reducing of the thermal load. Now they come to the cost benefit analysis. Of course, if you are the coal, biomass, oil, natural gas is the important point of view for the industry institutions because they are using for the different application, using for the various conventional fuels. So we need to think about the solar CST. Even concentrating solar thermal technology is one of the best options to provide the temperature 50 to 250 degree temperatures. Of course, we need to think about the CO2 abatement, and financial point of view, we need to look for the carbon credits for the industry's point of view. For the investment point of view, this is a roughly idea. I'm just sharing the cost economic like that. If we are talking for the 100 square meter, maybe they can go up to the 5,000 square meters. But as an example, we need to think about 100 square meter. The per square meter cost is 25,000 or maybe 35,000 square meter collector area. So that we will try to reduce the diesels as well as the LPG and some other conventional fuels. Accelerated depreciation benefit is also available. If they are using the CST technology, they can very easy to go for the accelerated depreciation benefit. And of course, this is the cost economics ratio. The major important thing is the reflectors. Of course, the mirrors are very important. So we need to think about, instead of looking for the plain mirror, we recommend to look for the solar grade mirror. So the systems are functioning more than 15 to 20 years. So the cost economics, selection of factors, and selection and the quality point of view is very, very important, so that the systems are functioning not even the 5 years, it goes up to the 15 to 20 years. So for the industries, they are very important and they are very concerned for the quality concern in compared to the institutions like that. Under the UNIDO GEF MSME projects, we are supporting identified 5 MSME clusters, and we are given some direct grant for the 30% for the demonstration and 15% for the replications point of view. So this is because the fund is available not more than 2 million square meter. So that is the way the ministry is just giving some target to fulfill the CST, so that in the futures they can replicate more in wastewater and other applications. Because process heating, the major chunk for the industrial wastewater treatment. So I'm just trying to cover 2 or 3 slides how the industrial wastewater treatment is very important using through the CST. Now, if we are talking for the JLD, because as the industries are very prominent for the decarbonizations, and the industry, like an example, a few of the leather industries or maybe some textile units, they are very prompt to looking for the JLD solutions. And CST is applicable in concern of using the different technology. And my concern is because as they are using the membrane distillation, it's very easy to integrate with the CST to give it to the complete solution, and they can try to at least 6 to 7 hour conventional load using through the some other application, some way of JLD process like that. Because this is a major chunk, I'm not going to details because everybody understand the industrial wastewater and wastewater, how we can try to reduce the things and see to the options. And we can think about if we capture more performance data for the wastewater in the some other places in Ranipet, definitely we will try to share all the industries, and they can think about how we can the CST will work in terms of wastewater treatments. As concerned to the water crisis, of course, the major issues are, of course, Chennai, Bangalore, Delhi. This is the major issues of the groundwaters. So we need to think about the desalination process. And I'm sharing the information. One of the area in the Vellore, which they install in desalinations using CPC technology for the desalination application. So we need to think about in some other countries, South Africa or some others, they can use for the desalinations, because the water crisis, we are not saying the water crisis, there is options, there is a possibility to look for some water process, fresh water, ability of fresh water using through the desalinations through the CST. And the technologies are very easy to integrate with the MD system, and we can, because our suppliers are very active and they can work very effective, integrate with the membrane-based distillations process using through the CST. you can try to see this is the three vertical components, the solar point, thermal storage, and existing systems. And you can try to see the existing systems there because the important thing is they are not allowed entering the wastewater treatments. There is using the heat exchanger, whatever the energy which they capture through the the existing systems, they can capture more heat using the C-state technology. And if the energy which they capture more heat, they can go for the thermal storage also. The important point of the pre-treatment as an effluent treatment coming from the different industrial process vary. It first need to treat it because, as you know, we need to think about the scaling of the technology because otherwise it's effect on the solar technology. So we need to think to provide complete solutions either through the heat exchanger or some other way, or maybe the pre-treatment of the water, slightly pre-treatment of the water using through the heat exchanger. This is the process of effluent treatment, pre-treatment, thermal energy storage through the membrane distillations. I'm talking for the CPC because, as you know, CPC is very easy to capture a heat like 80 to 90 degree temperatures. So instead of looking for the high temperature than the cost economics, CPC is comfortable to use for the wastewater treatment. The cost economics, if we're trying to see the triple effect operations and MD-based systems, of course, you can try to see that in the yellow lines, the initial investment costs are going high like that. But as in the futures, the cost will come down because the initial investment cost is high with respect to the solar. But drastically, the payback period, you can try to see the payback period up to the 20 years. Triple effect, it's increasing day to day like that, yearly wise. But if you are talking for the waste heat using through the solar, it drastically come down, and definitely in the futures, it's no investment cost. My observations of using, especially for the wastewater, industrial wastewater treatment based on the pollution potentials and CTP are established for the highly polluted rate category industries, such as tannery, textile, electroplating, chemical, and pharmaceuticals. They are thinking, and that is the way the UNIDO is pitching to adopt the technology. Earlier, we are trying to focus more in the power, process heating like that, as steam generations for the various applications. But the thermodynamics point of view, whatever the energy demand, we need to fulfill through the CST. So the process engineering is very, very important. And that is the way which we need to think about how we can try to provide the training for the trainers so that the people will understand, give it to the complete solutions. And it's in the future, the systems are not functioning, not failure in the futures like that. So the demand and meet are very important. So in that concerns, one of the technology which we are trying to install the system is run PET and integration, which is supported by the UNIDO. And that is the way which we need to think about the other industries to give it to the complete thermodynamic solution using for the CPC. This is some case study for they install the system in SKF in Mysore, India, using for the wastewater evaporation in Schaeffler dishes. Synthecam using in the paraboloid dishes in the pharmaceuticals. Mahindra and Mahindra, which they install in Chakan as well in the Nagpur. The technology which they install in 3 different technologies: Schaeffler dishes, Arun dishes, even in the compound parabolic collector. So I'm not going to details, but the industries have come forward to support how we can capture more heat in concern to the generation of heat. So this is the some small case study for the SKF. They're using the 256 square meter using the parabolic trough. Application is metal phosphatings. They install in system in rooftop like that. So we are not saying the space is the major issues. If the industries are come just to say the space is the major concern, how we can adopt the technology. So we have in lots of case studies, so that I can just provide there is a possibility to use either on the corrugated roof instead of RCC structure. So with respect to the RCC structures, the systems even in the supplier, they are trying to install in the corrugated roof. Distributed load is very important. India for using for this is the first technology which they use for the water treatment, wastewater evaporations. But the important thing is we need to think about the highly efficient technology so that the technology will replicate more in concern to the other industries. And they are thinking to provide complete solution instead of looking for some technicals and some others point of view. So Schaeffler dishes in Barmer, which they use for the water evaporation, they are the capacity is 10,000 liters, which they are evaporate, but process is very slow. So we need to think about how we can accelerate the process so that the evaporation ratio will increase more in compared to the others like that. So the selection of technology is very important. If we capture more heat, will provide more, will evaporate more wastewater. But important thing is ultimately the payback period and investment cost. Paraboloid dishes in Syntochem, which they install for the even in the process of chemical compound preparation of medicines. Right now in the pharmaceuticals industries, they are very active to use for, and they're just requesting to requesting for the CST how we can adopt the technology and integrate with the existing, because 2 points are very important. So UNIDO, which they are trying to look for the pre-feasibility report, is if the pre-feasibility is existing or is applicable, we need to recommend for using the technology. Whatever the technology is applicable based on the space, we provide all the information, and they are just trying to contact to the industries. There is no need to look for the some additional benefit which is coming from the government. They are very key and concerned of the quality and demand like that. Mahindra, they are using the compound parabolic collectors in some the degradation of engine parts in Nagpur. Salem Dairy in their system installed in rooftop. My concern to share some photograph, because as the important thing is the system which they are very easy to install in rooftop or sorry, in the ground space, in somewhere in the corner like that. But there is a possibility to install in rooftop if we distribute the load, and that is the way with which I am trying to consider a case study, so that the people will understand the industries are supporting like that. There is no big issue in concern to the space. Even in the hospitals also, some pharmaceutical sectors in Valshad, Honeywell technology. That is the way which I am sharing this technology used in 2 different places in Rajasthan and Andhra Pradesh. We try to see the 800 square meters, and in the NPTL they're using the 650 square meter. The changes of the size based on the ability of radiations. So assessment and is very important, and ability of ground radiations data instead of looking for the satellite data. This technology installed in somewhere in one of the system which they install in Uttarakhand. You can try to see the space is the major issues, but the technologies are still installed in somewhere, and the systems are functioning well in the Lysol like that in the Dehradun. This is the major constant, and the systems are functioning well. And you can try to see the corrugated roof, the system installed in corrugated roof in one of the industries like tea industries in northern eastern area. This is the system which they are, because the earlier solar water heating systems we have in a testing center, but this, we established 2 test centers under the UNDP programs with the help of ministry in University of Pune, and even in nice centers of solar energy for the testing of the CST technology, including some collectors and reflectors also. So my conclusion in that way of entire presentations, of course, the conducive atmosphere for tapping the potential of RE technology. Of course, the country, especially for the solar energy, for industrial and institutional sectors, whatever the applications required, the technologies are applicable, and they can very easy to integrate with the existing systems, either for the cooking, process heating, cooling application. Technology is applicable for the laundry, drying also. Drying is the major constraint, or some of the technology which they use for the drying in some ultramarines. For the earlier they are using for the kerosene. Now they replace all the things, and they're using the CST technology for the drying purpose. CST is finding good options for establishment to reduce use of fossil fuel. Of course, whatever the energy which we need to capture, definitely we'll try to reduce the boiler load. Maybe the 6 to 7 hour, whatever the peak load available in the during the sunny hours. So this technology will provide the energy in terms of whatever they demand during the sunny hour. But there is a possibility to look for the storage also, as in terms of pressurized hot water. I'm not talking for the steam generation, because if you are talking for the steam generation, the cost is the major issues like that. So if you are talking for the power generation, of course, molten salt and other things which they are trying to need like that for as a storage. But as in a process point of view, there is a possibility to look for the pressurized hot water storage tanks. I just shared this one of the case, one of the example for the RK missions. In the morning 4 o'clock, they are using for the cooking applications without any suns. So they are capture more heat and their storage is in terms of pressurized hot waters. So of course it's a win-win position for the end users as well as some other point of view for the, because they reduce the carbon footprint area. And if you are talking for the carbon footprint area, of course, definitely we reduce the conventional fuel. Is the cost effective, financially support available for the some clusters. So from my sides, I just cover all the points.
Yeah.
I'm very happy if somebody will ask the questions.
Thank you very much, Dr. Pankaj. Yeah, I just want to, before I ask others to comment, I just want to say that I was aware about the technologies which are there in Akshardham for cooking. You know,
Yes.
even in, I think, Moria Sheraton, they have that Arun dish. Then, of course, they have one in the classical example we used to show of Mount Abu, you know,
Yes, yes.
that the cooking there. But today what I've seen is many more applications, and your focus has been, and the zero discharge, that solar power technology, solar thermal technology, that zero discharge. Have you contacted CPCB? You showed one pilot plant on Rani Pet in Tamil Nadu.
Yeah. We are
This is a
trying to
major
share.
problem. The CTs, CPT, you know, CTPs, they are having very old technology. Their technology is very bad, and their discharge, you can say, I don't know. So have you contacted CPCB for taking it further?
CPCB
Pollution Control Board.
right now, because as you know, in the Tamil Nadu Water Investment Company, they are very close to interact with some clusters in leather industries. In Ranipet is one of the example. And they are thinking, because the system which they already tested, because the important thing is they are trying to replicate. And the one of the case example, which they install a systems, but still these systems are testing, because the last month they install a systems, and we need to look for the performance data. Of course, they committed to provide 1.5 ton per hour steams, and if we are talking for the 6 hours, it's major chunk like that. So we need to think about how the energy, because as concerned to the thermal efficiency point of view, they are very close to 78% efficiency we have in a data. So that is the way which we need to think about. If the technologies are working very comfortable for the wastewater treatment, drastically reduce the technology, the cost is not a major issue with respect to the technology point of view.
Okay. So I think we have Mr. Niranjan Khatri, who's there. And if he could like to make a comment. Mr. Khatri, please.
Dr. Pankaj, an excellent presentation. I have been chasing this technology for a long time. And I've always wondered, that's a no-brainer for all the large establishments, especially the factories, etc., to use this for, you know, catering to the 10,000 employees that they feed every day. Why has that not happened?
Sir, the important thing is, the important factor is demand and meets like that, sir, and the thermodynamics, which we understand, because earlier we are not very concerned to the thermodynamics point of view. Whatever the energy, because technology is not a big issue. They've generated steams like that. But the industry's point of view, they need to look for the functioning and energy, reduce the energy cost. And if the energy which is coming from the solars, they can try to meet whatever they demand. Definitely, they are trying to monitor the things. And that is the way the industry, earlier the industries are not come forward to support. But right now, the industries understand the operation point of view, we are very easy to maintain the systems. Like example of Brahmakumari ashrams. There is no any engineering background operators are there. But thing is there, how the systems are operated by the operators where the Brahmakumari ashram is in there. So in that way, the industries, they understand the operation point of view. Because energy, if they are not looking for the operation point of view, the energy will definitely, its effect on the technology and investment cost. And that is the way the earlier we are facing lots of difficulty and the systems are not functioning, even in the non-functioning. Right now, we need to look for the thermodynamics. And that is the way UNIDO is a very particular under the SDG 9 point of view for the industries. Because I'm not looking for the industries in India, I'm talking for the transfer of technology in somewhere also. So that is the way we need to look for the highly even demonstration project so that we can replicate to the some other countries also.
In addition to Brahmakumari, we have it there in Tirupati also, and in I think so in Sai Baba's this thing. There also we have those systems are also working, I think, fine. So I was not knowing the post things you have shown.
Yeah, yeah.
And of course, the zero discharge was very good. We have Mr. Khatri. Any more questions from your side?
That's all. Thank you.
Okay. Then we have Mr. Randir Singh. He is, from Bimberia Energy. They are doing a lot of work in wastewater. If he would like to comment, Mr. Randir Singh. Hello. Hello. Yeah. In the meanwhile, we can take a question from Mr. Mangesh. He wants to. He has raised it. Please unmute him, Mr. Rohit.
Hello, can you hear me?
Yeah, we can hear you. Yeah.
Yes.
Yeah, a nice presentation, really good case studies. But on an average, what are the typical ROI on an average for this type of plants? In one case study, you have told that you have shared that it is about 3.5 or 4 years. But what is the typical ROI for this type of projects?
Yeah, yeah. Because all the ROI depends on whatever the fuel which they are using. If you are talking for the coal, like example, coal, diesel, and some furnace oil, the cost is very important. If you are talking for the coal, right now, the current cost of the coal is near about 14, maybe the 14,000 rupees per ton, like that, or maybe because it's increased from 6.5 to 14 or 12,000 or 14,000. The payback of the system which we are using, the CST, without any financial support, because everything is depends on the energy requirement, energy demand. If we are talking for the 6 hours, 7 hours, definitely in the period of 250 days, the systems are functioning well. The payback will come down near about 7 to 8 years. This is the concern of coal. If we are talking for the diesel, like example of one of the case study in Natural Capsules Limited, they are trying to save 150 liters. You can try to see the 3 years. Earlier, they proposed 4.5 year. Now, drastically, 1.5 year they reduced. The system installed in March 21 and is still functioning. Right now, we visited as project sites, and the beneficiaries are very happy. And this is the way which we need to think about. We'll try to share all the performance data to the industries, or maybe if somebody will interested, you can try to visit to the Puducherry. In the system installed in Puducherry, the systems are functioning well like that.
Thank you, sir. Because ROI is one area where the corporates will be immediately making a quick decision. Because longer the ROI, higher the ROI, then definitely they will be hesitant in moving ahead in this direction.
Yeah, absolutely. And that is the way.
What is the major cost? Basically, what are the major costs going in? The cost of technology only?
Yeah. Because the cost will also depends on the selection of technology, right? I just shared the one example of Honeywell as well as in the Rajasthan for NPTIL, right? And the radiation that they selected a technology like parabolic trough collectors, but the same technology which they are using the Swiss embassy using for the cooling applications, right? Even in the Gandhinagar, Gujarat also, they installed 1,500 square meters for the cooling application. The cost for the CPC is very low in compared to the other technology. If we are saying something like that as in figure of INR, it very close to 20,000. But if you are talking for the paraboloid and parabolic trough, it depends on the energy demand. The cost will go up to 25,000-26,000 square meter per square meter collector area. It depends on the energy demand and size of the systems. Whatever the size, like 1,500 square meter collector area, the cost will come very close to 2 CR and something like that. So it totally depends on the demand and as well as the selection of technology.
We have Mr. Thomas also.
Thank you, sir. Thank you.
Yeah, thank you. We have Mr. Thomas also. If he would, he's also associated with the wastewater. If he is available, would you like to comment, Mr. Thomas? I'm slightly intrigued by his zero discharge, solar powered this thing. And I feel this is a big problem. And in fact, Dr. Pankaj, when we have got regular trainings for wastewater people, for wastewater treatment, we have regular trainings. This technology, when we have made the presentations in the curriculum, this is not there as a part of it. So when we do the trainings, I would like to invite you or give a small presentation to the trainers so that they can be equipped with more knowledge. They already have the regular technologies. That is why I was asking Mr. John Thomas. He is also a GIZ consultant for wastewater. So I don't know, he's not there. So I would wanted him to comment on what is this new technology and how it can be taken further in the wastewater treatment.
Yes, ma'am.
plants.
I'm very happy. If whatever we have in information, definitely we will try to share. My ultimate working with the CST in last 15 years, especially for the promotion of technology.
Yeah.
And that is the way which we understand how the CST, because my confidence for the CST is very, very important. But important thing is the process engineering. If you understand the process engineering, definitely the technology will drastically increase, because if we look for the potential point of view, 6.45 gigawatt in terms of square meter, it's very, very high like that. And that is the way few of the oil sector like ONGC is come forward to support how we can adopt the technology for the wastewater treatment, as in terms of JLD, in terms of drying process. So we need to think about, and that is the way, if suppose we'll cover, we'll collect all the performance data, because the technology, maybe the next years, the systems are functioning well like that, they install and they integrate. Whatever we have an information, and whatever you want, we'll provide all the information.
Yeah, I would like you to take a session there on this aspect. See, solar thermal, concentrating solar thermal, I had a lot of interaction. In Delhi government also, we were trying to, Thermex was trying to put the, the entire cooling of the CM's floor was, we tried.
Yes.
But the space was there, but cost was too much. So now with period of time, cost has also come up. And as you said, say space also is not a big limitation.
Yeah, ma'am.
But this something which I really am intrigued. Yeah. Any more questions? Yeah. If there is there any more questions, or if anybody would like to ask or comment something. I think I should now formally thank you, and I can ask Mr. PB Singh to extend a formal thanks to you and all the participants also. Mr. PB Singh, please.
Yes, thank you.
Thank you, ma'am.
Thank you.
Thank you, Dr. Pankaj, for the excellent presentation. And you explained very well with the examples and along with the case studies. So I think it's a very good presentation. Thank you very much. And I would like to thank all the participants for the participated today's webinar. Thank you very much to all of you. Thank you, Dr. Pankaj.
Thank you, sir. Thank you, sir.
Thank you once again from my side also, and have a good day.
Yeah, thank you, ma'am. Thank you. Thank you.
We'll connect with you. Thank you very much.
Thank you, ma'am. Thanks.